Hello class, so this is a video on Newton's second law. We did talk about it in class, but I wanted to go into further detail here. Do take notes. So the formal definition, I'll simplify it and write that in a second. The formal definition of Newton's second law of motion can be formally stated as the acceleration of an object as produced by net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. That was a word for. In general, we can say that the net force, so the total, which is essentially the total force, net force creates an acceleration in the same direction, right? If you push one direction, it's also going to accelerate in that direction. But the acceleration, however, is based on the mass. This is in very simplified terms. So the way that we sum that up as far as the equation is force, we'll talk about what this means, but that means it has a direction times the mass, or is equal to the mass times the acceleration. So I would definitely write this in your notebook. Make sure you know that F is force, M is mass, and A, hopefully you remember, is acceleration. Alright, write that down, moving on. So what we mean by F equals ma, say we have, for example, a brick. Let's say this brick is in space, so there's no gravity, it's just floating around. But, you know, maybe something hits it, like in this direction. So there's a net force in this direction. Alright, which way is it going to accelerate? Oh, well, it's going to accelerate in this direction because it got hit from going that direction. Alright, but let's say we now have a much larger brick, much more mass. We'll call this mass 1, mass 2. Mass 1 is definitely smaller than mass 2. Alright, we've got a huge brick. And we have the same exact force, I'll try to draw the same exact size, hitting it. Alright, force 1, force 2. These are equal forces, so you're hitting it with the same force. Does it accelerate just as much as the first one? Think about it. If you have something heavy, say you're pushing a shopping cart at Costco, best store Costco, if you in the beginning it's empty, and when you push it, it immediately goes fast. All right, you just put a little bit of force into it, and we're off. At the end, when you got a lot of mass in that cart, you're trying to push it, but it's harder. You must push harder to get it moving. So what do I mean by the mass? Based on the mass, it's only going to have a little acceleration, even though you hit it with the same amount of force, because there's so much more mass in here. This is what this formula does. The bigger the mass, the lower the acceleration. That's what they mean by the mass is inversely proportional. Alright, as this goes up, acceleration goes down. Alright, let's do some examples. Actually, before I get into examples, I want to talk about the fact that mass is definitely not the same as weight. So when you weigh yourself on a scale and you get, oh, you're what, 150 pounds. That is not the same as saying that would be about 70 something kilograms. These are not the same. Kilograms is a mass. The fact that they give you kilograms on a weight scale is actually just, they're computing it from the gravitational pull, and it's not actually accurate to call it a weight. This is your mass. They're different. Mass is how much stuff there is. Weight, hopefully you'll see, is from gravity, right? It's how much gravity pulls us down. Like, I would have the same mass on the moon, but I would weigh a lot less on the moon because the moon's gravity is much less. I'll have a full video on this later, but just make sure you remember mass is not the same as weight, although they are often confused. Alright, so let's say we have a problem. We have a brick that's being pushed with a force of 10 newtons. So newtons is our measurement for force. Newtons is equal to a kilogram meter over second squared, which if you'll look at your formula, that makes sense because you're going to have mass, which isn't going to be in kilograms, times the acceleration, which we know to be in meters per second, and then you get kilograms times meters over seconds. So those are your units for the newtons. If you write, you could also just write 10 kilogram meter per second squared, but that's a mouthful, so we tend to just write the N for newtons. Alright, and then the mass of it is 2 kilograms. So we have a 2 kilogram brick floating in space. Something hits it from the side with a force of 10 newtons. The question would be, what is the acceleration? So we have our formula, force equals mass times acceleration. We want to find acceleration, so we have to isolate acceleration. You divide by mass on both sides, those cancel out. You have F over m equals a, and all you got to do now is put in your numbers. So for F, 10 goes in. For mass, kilograms goes in, so we have 10 newtons over 2 kilograms gives you 5 meters per, I'm going to make the colors look nice, 5 meters per second squared. As far as the units, we have newtons on top, which is the same as kilograms times meters times second squared over the kilograms. So what you're doing is you have to cross out this kilograms, and you're left with just our meters over second squared, remember, which is what we want for acceleration. Alright, then I'm going to do one more problem for you guys to try on your own, but here was your example problem. Alright, to see the proportionality, we're still going to have a brick in space. It will still have the same force, where force is going to be, 10 newtons again. However, we're going to change our mass. We're now going to double our mass, so our mass is going to be, instead of 2 kilograms, 4 kilograms. What is our acceleration now? Go ahead, try that. Pause the video, try it. Alright, so again, you're still going to plug in, you have your formula, F equals ma. You must divide by m on both sides to get a alone. Then you need to plug in your numbers. Force is 10. Again, colors. Force is 10 newtons over 4 kilograms. Your kilograms kind of cross out with your newtons, so you end up in meters per second squared. And then 10 divided by 4 gives you 2.5. Now think about it. When we had the original mass of 2 kilograms, our acceleration was 5 meters per second. It was twice as much. So that makes sense. When we have a tiny weight, or a tiny mass, and a large mass, but you hit them with the same force, the tiny mass will accelerate faster. There's less stuff to move. It's easier to move it. So this kind of displays the proportionality between force and acceleration and how mass affects that. Alright, hopefully this helped you learn a little more than you know, and I will see you tomorrow.